In 2003, a single Kornet anti-tank missile punched through the frontal arc of an M1 Abrams. The armor that was designed to stop everything didn't. The question is not why the Kornet worked. The question is what the United States Army engineered in response. The 9M133 Kornet is a Russian-designed laser beam-riding anti-tank guided missile that entered service in 1994. It was built with one specific engineering objective: to defeat the composite armor systems that NATO had developed through the 1970s and 1980s. To understand why the Abrams needed a new answer, you need to understand precisely what the Kornet does and why the Chobham armor package, formidable as it is, was not designed to handle it alone. Traditional anti-tank rounds are kinetic. They defeat armor through velocity and sectional density. A tungsten penetrator traveling at 1,700 meters per second overwhelms material resistance through sheer physics. The Kornet operates on a completely different mechanism. It is a shaped charge weapon. Its warhead uses the Monroe effect, a focused explosive jet that concentrates detonation energy into a narrow, high-velocity stream of superplastic metal moving at approximately 10,000 meters per second. This jet does not push through armor. It penetrates through hydrodynamic pressure, the same principle that allows water to cut through steel at sufficient velocity. The standard Kornet warhead carries a tandem charge. The first charge, the precursor, is designed to trigger reactive armor systems. The second charge, milliseconds behind it, penetrates through the exposed base armor before it can reset. Chobham disrupts kinetic penetrators by destroying their geometry. Against a shaped charge jet moving at 10 kilometers per second, the disruption window is measured in microseconds. The ceramic layers still provide significant resistance, but the tandem charge configuration was specifically engineered to defeat layered composite armor. This is the engineering problem the Abrams faced in Iraq and later in conflicts across the Middle East where Kornet systems appeared with increasing frequency. The Army's answer was not more armor. It was a faster system. The Trophy Active Protection System, designated MAPS in U.S. Army integration, is a hard-kill APS developed by Rafael Advanced Defense Systems and integrated onto the M1A2 SCPV-2 and SCPV-3 Abrams variants beginning in 2019. Its architecture has 4 distinct engineering layers, and each one needs to be examined precisely. Layer 1, Detection. Trophy mounts 4 flat-panel radar arrays on the turret, providing full 360-degree coverage. These are active electronically scanned arrays, ASA radar, operating in the millimeter wave frequency band. The system scans the environment continuously, building a threat picture of all objects moving toward the vehicle. The radar does not simply detect presence. It classifies trajectory, velocity, and attack angle in real time. The processing architecture must distinguish between a Kornet missile traveling at 300 meters per second on a direct attack vector and a rock thrown by a child at 15 meters per second on a ballistic arc. That discrimination must happen in under 1 second. The consequences of misclassification are either a missed intercept or a countermeasure detonating in an area with friendly forces or civilians. Layer 2, Tracking. Once a threat is classified as a valid engagement target, Trophy transitions from detection to fire control tracking. The system calculates the intercept point, the precise location in 3-dimensional space where the countermeasure must arrive to neutralize the incoming round before it reaches the hull. This calculation accounts for the Kornet's guidance behavior. The Kornet is laser beam riding. It steers itself along a laser beam projected by the operator toward the target. Its flight path is not purely ballistic. It can correct in flight. Trophy's fire control must lead a maneuvering target while simultaneously validating that the intercept geometry keeps the countermeasure blast away from dismounted infantry operating near the vehicle. Layer 3, Intercept. The countermeasure is a directional fragmentation charge, a controlled blast of projectiles fired from one of 2 launchers mounted on the turret. The blast pattern is precisely shaped to intersect the incoming missile's flight path at the calculated intercept point. The Kornet's shaped charge warhead must be defeated before it reaches its standoff detonation distance from the hull, typically 1 to 3 meters. If the warhead detonates inside that window, the shaped charge jet still has sufficient coherence to penetrate. Trophy's intercept geometry is calibrated to engage at a distance that disrupts the jet formation before it achieves full focus. Layer 4. Reloading. The trophy system carries multiple countermeasure rounds per launcher. After an intercept, the system automatically assesses the threat environment and recycles to a ready state. The reload sequence is mechanical and requires no crew input. In a multi-missile saturation attack, a tactic documented in Hezbollah operations using simultaneous Kornet pairs, Trophy can engage sequential threats within the same attack window. This is the specific engineering scenario the system was validated against. 2 Kornet missiles fired simultaneously from different vectors to saturate a single tank. The Trophy solution was dual independent launch sectors, each tracking and engaging separately, with overlapping coverage arcs. Step back from the engineering and examine what this system represents strategically. For decades, the asymmetric threat calculation in armored warfare was straightforward. A missile system costing tens of thousands of dollars could destroy a tank costing millions. The economic equation favored the attacker. One Kornet team with a launcher and a trained operator could neutralize an Abrams that took years and hundreds of millions of dollars to produce. Trophy changes that equation. The system does not make the Abrams invulnerable. No engineering system does. At sufficient saturation, enough simultaneous missiles from enough vectors, any active protection system will be overwhelmed. This is known. It is the basis of swarm tactics being developed by peer adversaries. But the operational threshold for defeating a trophy-equipped Abrams is now significantly higher. A single Kornet team is no longer a credible tank killer against this platform. That changes how opposing forces must resource and coordinate anti-armor operations. It raises the cost of the attack. And in military engineering, raising the cost of the attack is often as strategically valuable as making the attack impossible. The Abrams did not become invincible. It became significantly more expensive to destroy. We opened with a Kornet punching through Abrams armor in 2003. That missile worked because it was engineered specifically to defeat the armor that existed at the time. Trophy exists because the Army engineered a response to the missile that defeated the armor. This is the permanent logic of military engineering. Every system creates the conditions for the next system. The Kornet was the answer to Chobham. Trophy is the answer to the Kornet. Somewhere, in a defense laboratory you will never hear about, an engineer is already working on the answer to Trophy. The machine is never finished. The threat never stops evolving. And neither does the engineering. Tactical ledger. The engineering behind the machine.